All right, so just an overview for the activity confidence intervals means with known sigma. All right, so we're going to apply what's called the central limit theorem, and what we end up getting is a relationship that exists for all possible samples of size, whatever it happens to be. So in this case, average price of 40 recently purchased Westchester homes, right? So the central limit theorem tells us that the mean of all of those samples, when averaged together, so if I have, just imagine I have a population, because there's definitely more than 40 homes in Westchester. So if I have, let's say, 100 homes, and I sample 40 of them, but then I do that again and again and again until I have all possible samples of size 40 from the population. I get the average for each one of those samples and then average those averages. I end up with the mean of the sampling means, right? This notation just tells me that that number is going to be equal to the population mean, right? So it's kind of a little mind bendy, but if you think about it, you get there, right? So the population mean, the average price of 40 recently purchased homes taken using a simple random sample was 730,000, right? The standard deviation of those of Westchester homes in general is 60,000, right? So we're looking at the mean of the sampling means being equal to the population mean, so that's just going to be 730,000. My standard error, which is the population standard deviation given here, divided by the square root of whatever the sample size is, right? So in this case, that sample size is 40. So I'm going to do equals 60,000 divided by the square root of 40. So that's my standard error. Now, for a 95% confidence interval, and actually, it's kind of weird why, I'm not really sure why I put 95 first, then 90, then 99. Let me change that. This should be 90. This one should be 95. And this should be 0.10, and this should be 0.05. By the time you get the actual link for this, it'll be updated, so you won't have to worry about it. All right, just double checking, making sure everything else is the way I want it. Okay, so for the 90% confidence level, we have an alpha value of 0.10. All right, that 0.10 corresponds to the outer 10% in the normal curve. Right, so I want to figure out what that corresponds to in terms of a z-score. All right, so I have the solved example here. If you want to just go in, you could just kind of copy this, because it's a fair amount of stuff that we're incorporating. So I'll talk about what the individual ingredients are, but for now, let me just pop it in there. All right, so we only want a positive number, so I'm going to throw an absolute value on it. This is the inverse normal probability model, right? So what I want to do is take that 10%, that 0.10, so minor edit here, and divide it by 2, because in a normal curve, if you're looking at the middle 90%, then you're really saying, okay, I don't want the outer 10%. But since it's symmetrical, we divide it by 2, because you have 5% on one side, 5% on the other side, totaling out to 10%. All right. And then 0, 1 represent the mean and standard deviation for a standard normal curve. All right. So those you're not going to change. I just realized up here I want to change this to 90 and this one to 95, just for consistency. Okay. So I have that value. My low bound is going to be whatever the mean of the sampling means is, so equals this number minus my z-score multiplied by my standard error. All right, so that's my low bound. My upper bound is going to be all that same stuff, just with a plus sign. All right, so we can conclude here, so we are 90% confident that the population mean price of a home in Westchester is between this number and this number. All right, so I'll just type that in, and I'll show you a little trick. It's something that we've used before, but I don't know if you've necessarily needed to do this on your own, but I'll walk you through. It's the concatenate function. So let me just type this real quick. 745,604.45. All right, and we can expand things a little bit just to make it a little bit more appealing. So that's my conclusion statement. And if I'm looking to purchase a house, I can say with 90% confidence that I'm probably looking somewhere in the low 700,000s, right? This is outdated information, so it's probably different from that now, but you know, it gives you a general idea, because now if I wanted to, I can test this out for, maybe I did a simple random sample of 40 homes and it turned out it was 800,000. If I change this, everything else will change around it. Right, but if I want to avoid having to rewrite my conclusion over and over again, what I can do is use the concatenate. So I'll do it down here. Equals concatenate. I would want the we are 90% confident, and if you want, you can actually, you know what? I'll do that. I'll make a little update here. So I'm going to call this C level or confidence level, and I'm going to put this 90% in here. I'll show you why in a second. And I'll update this also. Same idea here. And I'll highlight. Okay. And again, all these edits will be on your on the file that you get. So what I'll do is comma 90% comma confident. Now let me just show you real quick. I'll just leave it at that. We are 0.9 confident. Well, that's kind of annoying that it converted it over to decimal, but that's perfectly fine. All right. There's ways around that if you want. For example, instead of putting the percentage in there, we can build it into the concatenation statement. You know, so we could do it that way. So I'll make this a little update also. So we are 90% confident that the population mean, this is one thing you'd have to update because the context is going to change from problem to problem, but we're doing 3 conclusion statements that are all related to the price of home in Westchester, of a home in Westchester. So we can make use of this concatenation statement at least 2 more times. All right, so population mean, price of a home in Westchester is between this right? So I'm gonna put a $sign there. So this and another $sign here. This. And, you know, just make it somewhat grammatically correct. I'll throw in a little period at the end. All right. And I'll do format, wrapping. I'll just wrap it up. All right. So we are 90% confident that the population mean price of a home in Westchester is between this number and this number. It didn't round it. If you want, you can throw a round statement in there, right? It's up to you. Oh, or you could just copy, paste, and edit as you go. I'll just leave it up to you how you want to do this, right? So, yeah, so not too bad. I'm just going to change these while I'm here. You get the magic of watching me edit a file that I probably should have edited before starting to record a video. Right, so the only thing that's going to differ from problem to problem is the confidence level, right? So at the 0.05 level, so I'll just pop this in there. I can close this up too. So now I'm at 0.05. That changes that. These two things, I mean, you can just do it one at a time if you want, copy, paste. If you want to lock the references, you can, and just go from there. So I have mine in C2. I'm no longer looking at B6, now I'm at E6. But C2 and C3 are going to stay put. All right, so I got this one. Change this minus to a plus, and now I have that. And if you want to go with the concatenation, you can do that. I'm looking at E5. I don't believe I hit a 5. Yep, that's what I wanted. So we're 95% confident that the population mean price of a home in Westchester is between, we need the low bound and the high bound. It seems to think that it's in D7 instead of D8. I'm not sure why that happened. Oh, because I moved it back up a row, so it reduced my row reference by 1. All right, so we got that. Make it nice and yellow. Actually, I can delete this now because it is no longer necessary. All right. Get rid of this too. Reset. So same idea. Copy. This one we're doing 0.01. Still looking for high bound, low bound. See what it's pointing to. Oops, sorry. I didn't want to do just a direct copy. I wanted to actually go in it and then update the references. So this is now H6. And same idea, grab this, change the minus to a plus. So really, I mean, this is this way for a lot of assignments. We're doing a lot of copy pasting and updating references, right? It looks like it's pointing to the right stuff now, so I feel pretty good about this solution. All right, I have a second example here, same deal. We're gonna go 90 first and then 95 and 99. Okay, this time we're given a set of raw data, but we're gonna do the same stuff. All right, so let me steal my stuff from over here. Just update some things here. This is 95 and 99. For our purposes, it's always going to be 90, 95, and 99. So we can kind of rely on that, right? The mean of the sampling mean, so this time they didn't give it to us, but we'll find the average of the values in this set. Oops, not a whole heck of a lot of them. we're going to divide by the square root of n, whatever the population standard deviation is. So equals standard deviation. We're going to grab for the population. Same references. But we're going to take that number and divide it by the square root of however many values are in this set. I'm going to use a count, just so I don't have to actually physically count it. All right, so close up the parentheses for the count and for the square root. And now I have a value here. Just so I can actually see it, I'm going to take it off the center. I could also expand the column if I want. All right, so this is my 0.10. These two are now backwards, so quick fix. And the last one should be 0.01, so we're good there. All right, so same idea. We're going to grab this number, just pop it right in. All right, it's referencing the right stuff because it actually isn't referencing any rows or columns. It's just a straight calculation. So this really is just a quick copy paste down the line. So pop it in there, and the last one. There we go. So my low bound and my high bound, same idea. I'm just going to grab the first one here, update what needs to be updated, and go from there. All right, so on my low bound, I have my information is in F15. Then E18. And I accidentally dimmed the screen there. And then F16. Okay, so lock that in. Minus goes to a plus. So still F15 and 16, but this time it's referencing E26. Minus goes to a plus. Same idea here. This time we're looking at E34. Minus goes to a plus. Then it's just a matter of getting our conclusions in. So I'll grab this one, paste it in. All right, the references, they need to be updated. Oh, that's actually the one I hand typed. So let me grab a different one. All right, looks like it's pointing to the right stuff. 90% confident. The mean price, these are still Westchester homes, I believe. Yep. Between 552,000, which I see here, and 773,000. Looks good. As long as it's pointing to the right stuff, we're in good shape. Good and good. So that's what I meant before when I was saying that using the concatenation function can be really helpful, because you can see here I didn't have to type in the conclusion over and over again. Right? I just did it once or twice, and then I just used the fact that these are formatted the same way to help me write the full-blown conclusion using the concatenation option. All right, so that's that, and you're on to your assignment. You can see I put the little statements in there. You can edit it. You could use concatenate. It's up to you, but really you're just pretty much doing what we just did, just with some slightly different numbers. And again, I'll just update this.